People sometimes find it confusing to relate to circumference and area when it comes to circles because the formulas look similar. I'm trying to make sense out of a little bit of both. Just watch my hands, I'm cheating here. On this circle, you can see I drew it on the square grid. The radius of the circle is marked in blue and it's exactly 3 squares. The diameter of the circle is twice that. The diameter of the circle is exactly 6 squares. Right away I want to point out one thing. The radius is a linear measurement. Linear means that you measure along a line. The radius, in terms of terminology, it's a strange word, but it means length. It means a special kind of length. The length from the middle of the circle to the edge of the circle, but nevertheless it is a length. Diameter is also a length. It means the length from the edge of the circle to the edge of the circle going through the middle. It's also a length. It's a special kind of length, nevertheless it is a length. The next word in it is circumference. Circumference. Circumference is a length. Circumference means the distance around the circle, and it is a length. I'm going to measure it with this piece of wire that you see on the paper. It is a length. So let's get to work here a little bit. The circumference of the circle is calculated with the following formula. You might be familiar with 2 times r times pi. And I'm leaving out the notation for multiplication, so it could be a dot or an x. I don't want to do x's. 2 times r times pi, that's what it is. Or just make sure you don't make a fuss or an argument, don't get into an argument about it. It can be r times twice pi, radius times twice pi, because it's going to be the same. On this particular circle, radius is 3. So you can either go 2 times 3 times 3.14 or 3 times 2 times 3.14. I know we're not doubling pi, technically, we're doubling the radius. Don't worry about it. It's going to be the same. Or, if you are like me and you like the fewest possible letters on a sheet or in a formula, I just go with diameter pi. Multiplication between the two of them. Like I said, circumference is a length, just like the word perimeter is also length. But I don't want to write on it because it doesn't relate to circles, but it's also a linear thing. If I start going around with this flexible piece of wire and go around the circle just like so, that's a pretty good fit there. Good there, good there, and there. You can see that this wire is there. That's a pretty good approximation for the length of the circumference. Okay, it's not entirely 100% good, but close enough. So I just want to mark it on the piece of copper where they overlap. There, take a look. There's the mark. There, that black dot is the mark. And if I pull out the circumference, it is a length. So let's start with the end of the wire somewhere there, say thereabouts. Let's start counting there, and we're gonna be finishing there because that's where the mark is on the piece of wire. And if I count the squares or the length of line here, that's 1, that's 2, and that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and a wee bit. That little bit, 18 and a little bit, that's more than half, maybe more than 3/4, something like that. But if we do the math, we shall get a precise number. The diameter is 6 times pi equals 18.8. So the circumference of the circle is 18.8. So in that case, this one is the 0.8 part of it. So that's what I mean by circumference being linear. It's a length. Okay? Now area. Its area is going to be here. Area is a different concept. Area means filling this shape out with the squares, square tiles to be exact. I'm going to be working on just a quarter of a circle, and I'm going to just multiply it by 4 if you're okay with that. Let's do that. So in a quarter of a circle we've got 1 full square for sure. There's another full square there. There's a third one here, and there's a 4th full square. Now the rest of the circle will need to be approximated a little bit, but just so I can give you a visual on how many tiles cover this circle. Here is a little bit of a corner there. Let me just get closer there, and I want to use that little corner to fill in there. Hope you can see that one. That's good. And in that case, I want to call this one square number 5 with that little piece filled in. Now this one is approximately half a square. Half a square technically would be from corner to either from corner to corner. This is half a square, or half a square this way. Oh, that's ugly. There. That's also half a square. Alright. This one is approximately half a square. It's not along a straight line, and it's neither from corner to corner on a diagonal nor going from here to here, but this little bit of distance here at the bottom is about the same little distance. The same little offset here is about the same little offset amount there. So it's about half a square, because it's close enough to running either along a diagonal or along half a square that way. Okay, so just give me a little slack and let's call this one half a square. Now if we did that one with that square, we have the same situation with this square. This square has the almost exact same situation as this square here. The circumference is offset from the corner about that much there, and offset from that corner about that much there. And even though it's not a straight line, it's about half a square here. Okay, so we have 5 full squares plus half, that's 6. And I know that there's a little bit of area that we did not consider, but let's call that one the 7th square, okay? So 7 squares roughly tile over a quarter of a circle. So and we have 4 quarters in a circle, so that's 7 times 4 is 28. So the area of a circle would be approximately tiled over with 28 squares. The area is not a length. I can't show you where 28 is on a ruler. It doesn't happen. It's not a length. It's the number of tiles that cover over a circle. The exact formula for area is radius square times pi. If you want to use the other kind of formula that has diameter in it, you can go diameter square times pi divided by 4. The square of diameter multiplied with a quarter of pi, or you can divide that one by 4, or whichever way you like writing it up. You can watch another video of mine on it where I explain where this formula comes from and how these two are related. Either which way, what I do want to point out is that this number 2 here is squaring, and that number 2 there is doubling. That number 2 there is in the upper right hand corner, and its meaning is that you take the radius, I'm just going to rewrite it, and you times it by itself, and then you times it by pi. The area of the circle is radius times pi. The circumference was double the radius and then times it by pi. That's doubling, that's squaring. Totally different concepts. Whichever formula you're going by, make sure you know what you're doing. If I follow this formula, the radius is 3. 3 times 3 times pi equals 28.27. The area of this square is 28.27. We approximated it to be 28. It's a little more. That's the accurate answer, and that's kind of close. But just to get back to my point, those are some of the differences between circumference and area, between a linear measurement and an area measurement. And that's tiling over. So watch out for that squaring in the area. And in this case, if this was, say, centimeters, the area of this one is centimeters squared. If this is centimeters, again, the unit of measurement for circumference is just centimeters, because you can read it on a ruler, 18 centimeters. Sorry, 18.8. But there is no rulers for centimeters squared. That's why area is not measured, area is calculated. Only length type things can be measured. Okay, so watch out for these little details and make sure you know what you're doing.